All right, welcome everyone. Today we're going to be talking about object-oriented programming. In part one, we'll be covering what is an object. We'll talk about what is object-oriented programming and why object-oriented programming came about. We'll talk about the 5 pillars of OOP, how to go about creating our first class, what the init method is. And then in part two, we'll talk about what are getters and setters, implementing getters and setters. That will lead us to a kind of nested question, not necessarily a rabbit hole, but something that will help us understand how getters and setters actually work in the background is what is a decorator. And then finally, we'll build a roadmap together through TL Draw about how a class goes from being placed as a blueprint and then initiating an instance of the class. And we'll talk about that vocabulary as well as we go through this lesson today. At this point, does anyone have any questions over the material that will be covered today? Just a friendly reminder to everyone, everything that will be covered over this week will be in your assessment, your very first assessment that comes out this Friday, and it will be administered through test-driven development, just like you did with the practice assessment from this past Friday. All right, perfect. With that said, let's go ahead and dive into it. So, intro to Python object-oriented programming. Before we start talking about object-oriented programming in general, we have to understand what is an object. Now, typically when we hear the word object, we think about JavaScript and we think about the data structure that comes in with curly brackets, right? Or maybe if you're more familiar with Python, we're talking about a dictionary in this case. Now, when we're talking about object-oriented programming, we're not just referencing something that has a key value pair. An object is actually a real-world representation of an object that you see in real life. For example, your monitor. That would be an object in itself, right? Now, if we talk about it from a programming perspective, as you'll see later on, object-oriented programming came about with the idea of enforcing the dry concept, which is don't repeat yourself. Essentially, developers figured out that specific tools or specific algorithms needed to be reutilized over and over and over again, or many instances of one thing that had a lot of commonalities needed to be remade over and over again with just small changes in the property values. The answer to that was to implement something called object-oriented programming. What an object is, in reference here, is going to be a class. Right? So what we're talking about is building classes. Classes have attributes, and those attributes will be manipulated so that instead of recreating the entire wheel every single time we need a new instance of this class, all we have to do is feed it new attributes. All right. Now, a lot of that may sound confusing, but it's all going to come together as we see these images and we go through this PowerPoint and actually get some hands-on once we start coding some information. So overview, intro to object-oriented programming. What are classes? How do you instantiate an object with the init and self method, instance methods and self, and the dunder method. Now, all of this material you'll be tested on in your assessment 1 at the end of this week. At this point, does anyone have any questions? Perfect. Oh, go ahead, Angel.
And so this is all going to be tested at the end of the week, but is there going to ever be a chance to review the practice test we take or no?
We could definitely review the practice test this afternoon.
Okay, thank you.
Of course. Alex?
My Wi-Fi cut out there for a second. Was objects defined?
Yes. So in reality, what we're talking about when we say object is going to be a class. We'll see that here shortly.
So they're interchangeable?
They're not interchangeable. An object would be something in... So in JavaScript, when you hear object, you think about the curly brackets, right? Whereas in Python, we're thinking about dictionary. They're not necessarily interchangeable. A class works differently, and I'm going to dive into that here shortly once we start building classes, and then I'll really point out the differences between what an object is and what a class does behind the scenes.
Got it.
All right, perfect. Now, what is object-oriented programming? Can I get somebody to read this slide, please?
Yeah, I got it. Object-oriented programming is a programming approach that organizes code around objects, which are representations of real-world entities. It focuses on breaking down complex problems into smaller, manageable pieces called classes that have properties or attributes and behaviors or methods. By using OOP, we can create reusable code, promote code organization, and simplify problem solving by modeling the relationships between objects.
All right, fantastic. Thank you. Um, Earlier this week, you guys saw me solve an algorithm, or excuse me, not this week, the week prior to this. You guys saw me build an algorithm, and as I was going about solving the algorithm, I ended up building something called utilities, right? Which were just nested functions inside of a higher function. Now, when you think about methods, methods are behaviors or functions, right? That's what a function is. A function is a behavior. It may or may not take an input, but it should provide an output. Now, when I created this algorithm and I utilized a nested function, once we start working within classes, all of those nested functions are going to be turned into methods. And we'll see that again as we continue on with the program. All right, so what is a class in Python? In object-oriented programming, Python classes are blueprints or templates that define the structure and behavior of an object. Now, classes encapsulate data, which are attributes, and functions, methods, that operate on that data, allowing for modular and organized code. Now, that's a lot of text. If there's anything that you're going to take out of this, what a class is, it's just essentially a blueprint. It's a step-by-step, this is how you build this information. And I like to utilize the iPhone specifically because, every 2 or 3 years, there's a brand new iPhone that comes out, right? And there's just one new feature that gets added in there. So essentially, what we have is a class, a blueprint of how you build an iPhone. And then we're going to feed it materials to actually create an instance, which is what's in your hand of your phone. All right, so a class, again, is the blueprint. The instance is what you actually hold, the actual object being created with attributes and methods activated and ready to work. All right. Any questions up to this point? Okay. Now let's talk about the 4 pillars of OOP. In OOP, there's going to mainly be 4 pillars. If you ever get the question, what are the pillars of OOP? This is the acceptable answer. You'll need encapsulation, abstraction, inheritance, and polymorphism. You'll be able to find this inside of our curriculum. I'm going to send this in the Buffalo channel so everybody has access to it. If you scroll down, Buffalo questions, excuse me. If you scroll down a little bit in this first lesson, you'll see that there's a highlighted portion talking about the 5 pillars of OOP. So you'll be able to copy that down. And well, wait a second. We're saying in the curriculum there's 5 pillars, but here in the slide deck we see 4. In the case that you get asked what are the 5 pillars of OOP, the missing pillar here is going to be composition. It's not always included as a pillar of OOP for some reason, so we don't like to put it on the slide deck. It's more of additional information in case you get a weird question. Or if you just want to, if you step in an interview, they ask for 4 pillars, you could always mention, I know there's a 5th, and it's composition in this case. Now, what are each of these pillars? Encapsulation and abstraction. So encapsulation is a specific data can be restricted from the rest of your code. Well, in this example specifically, there could be many apps that are inside of this iPhone, right? They could all be placed somewhere differently. They can be inside of, some of them could be downloaded, but not actually being displayed, could be hidden inside of the iPhone. There's other mini applications that are running in the background of the iPhone, and that's an example of abstraction. So logic and complexity is hidden for simplicity, right? When I open up my calendar, I'm not seeing all of the code that's needed to run my calendar. All I'm actually seeing is going to be the user interface that I need to be able to have a good experience with the instance of this class, in this case, my phone, to make it work the way I want it to, make calendar updates, or anything that I need within the phone. Again, encapsulation is restricted data from the rest of your code. meaning that there's no clash between one application to the other application. They all work independently. Data is restricted. They all have their own methods and attributes. And then there's abstraction. The user doesn't need to see this. It's just our problem to handle all the logic and complexity. The user only needs to be able to understand, if I click this, this will do this. All right. Now, inheritance and polymorphism. Inheritance, which is sharing of similar features and attributes. And then polymorphism. We'll talk about polymorphism here shortly. So inheritance, again, we'd like to utilize the iPhone because they're not remaking the entire blueprint of the iPhone every single time a new iPhone is released, right? They're not starting from scratch. They're not crumbling it up. They're not going with a brand new designer. No, iPhones are very similar with very small changes. Those small changes were large enough to where a new blueprint was required, not built from scratch, but rather with alterations. But it inherited from its previous state, right? So the iPhone and the iPhone 2 have a lot of similarities between one another with just small changes. The inheritance part would be where the parent is the iPhone and the child is the iPhone 2. And then polymorphism. So objects can take in different forms depending on their needs. And for polymorphism, I like to utilize a different example here. We'll talk about it here shortly, I believe. Nope, we won't. Okay, so for polymorphism, objects can take different forms depending on their needs. A good example to think about here are the different platforms that are available to have meetings online. We have Zoom. At one point, Skype was very popular. I'm pretty sure Skype is still a thing. And then now we also have Google Meets available to you, right? You still have Microsoft Office, which can set up calendar invites or set up meetings for you as well. So there's a couple of different platforms that will allow you to do a video chat. And when it comes down to it, that's all that's happening. We're having a video chat. Now, the polymorphism part is the end state is still the same. We're still having a video chat, but the need for each one of them to work with their independent platforms is different. Chats are handled differently. Transcripts are handled differently. When I record on Zoom, it doesn't work the same way when I record on Zoom as if I were recording inside of Skype or if I was recording inside of Google Meets. Each one of these platforms, although they accomplish the same goal, they do it in a different manner. All right, so that's polymorphism there. At this point, does anyone have any questions over those 4 pillars of OOP? Let's hear it, Chris.
I was curious, was it inheritance? Can that happen? Is that within the object or can that happen between objects?
It can happen between objects. It doesn't happen within it. It is a process. Here's the way to think about it. Let me go ahead and do it this way. So when it comes to inheritance, we have our original blueprint here. Just gonna put original. This is a lot smaller than I thought it would be, so let me zoom in a little bit. And let's say we want to create something new, right? So this is the new class. Well, when the new class is created, I don't want to have to recreate it from scratch. So instead, I make a copy of the entire original blueprint and then add a certain level of new attributes and or methods. And that would be inheritance, right? Where the original class just gets reutilized down below. Does that answer your question, Chris? Perfect. Alex?
I got 2 questions. The first one will build on top of this. This new class, it brings in in terms of inheritance. Do the features have to be new, or is deletion also a way to go about inheritance?
You won't be able to practice deletion within inheritance. And let me change this new here. It could either be new or it could be, I'll say, different attributes or methods, right? Because we're looking at polymorphism in that case, if we do that. But you won't be practicing deletion between an inherited class, right? The expectation is that if you're inheriting a class before you, you would have, at minimum, all the same attributes and methods. Does that answer your question,
Yeah.
Al?
Yes. And
Okay.
then the second question would be, these four pillars, are they describing how maybe two classes interact with each other, two or more classes, or one class?
They're essentially describing to you what an entire program that's built on OOP principles would look like, right? It's not necessarily just in the scope of one independent class. It's saying if you're writing a program utilizing object-oriented programming principles, because it's a new style of programming, right? Up to this point, we've been doing functional-based programming. Once you start diving into object-oriented programming, all of these pillars should be implemented as much as possible. Does that answer your question?
Understood. Yes.
Okay, perfect. Any other questions? Okay, perfect. Let's go ahead and keep moving forward in that case. Now, this is going to start talking about getters and setters. I don't want to open this up until we get to part 2, because it could add a little bit of complexity, and seeing the slideshow might clear things up a little bit. So with that said, let's start building our class here, or taking a look at some practical application. And what we're going to work with first is going to be a dog. I'm going to be referencing this image a couple of times. Here we have an instance of the dog once the dog is actually created. And then at the very top, we're seeing the class declaration. So this is when the class is first being built. Well, let's dive into this first portion here of the class declaration. All right. So you can see that I already have a script pulled up in my terminal. I can already see that the script is working well. I executed the script and I see hello Buffalo. So everything's attached. But let's start talking about this OP here. So first things first, we're going to talk about the class declaration. And I apologize. It seems like Copilot's getting in the way. So I'm just going to snooze this as much as possible really quick so it doesn't get in the way anymore. All right, so what is the class declaration? This is where the blueprint of a class is written out in Python. Well, interesting. I say written out in Python. That means that there's got to be a couple of different ways to visualize what our class declaration would look like. Well, I know that what I'm going to create here is a class of dog, not a specific dog, but just a dog. And for now, I'm just going to pass. Now, this is the declaration of a class. When this class now exists within my program, even though it doesn't have any attributes or methods, my script can recognize that what I'm working here is a dog class. A keyword to establish this was the word of class. And then anything following that class will be what essentially the alias of this class that we're building. Notice that when I wrote out dog, I don't have a lowercase d, right? I went ahead and made it uppercase. When you're building classes, you're going to go back to the camel case style for naming convention. So naming convention for classes is camel case. And I guess it wouldn't really be camel case. It's essentially where every single word starts off with an uppercase letter. All right, so here's a dog. If I had a separate dog, that was, let's say, a specific one, it will be a German Shepherd. And hopefully I spelled that right. And if I were utilizing inheritance, it would look something like this, where I now have the dog. All right. We're not going to dive into that just yet. Just an example of the syntax and how everything falls in line. All right, so here we have our class of dog. And as we saw our class of dog earlier, it's the declaration of the dog. There's a couple of things here. If we zoom in, we can see that this dog has a name. Its name is Shadow. It has a temperament. We can see that there's an establishment, a specific breed, a group of origin, color, weight. So this is another way to visualize what my class should look like. Well, let's say I want to turn this into my, into my Python script, right? I want to turn that blueprint into Python code. I could do something like dog dot, and then try to add an attribute here where I can say name is equal to shadow, but that's not going to be very effective, especially if I'm dealing with multiple dogs or hundreds of thousands of dogs. Let's say I was running an impound and I'm trying to build a program for them to manage all the dogs that are coming in. That's not going to work very well. So instead, what we're going to be diving into is going to be the init method. Now, the init method is utilized as a constructor, which means that it builds an instance of the class with the appropriate attributes. So now we have our class of dog, and I'm going to create something called an init method. Now, a method doesn't necessarily follow any separate syntax here. It's still just a function. You can see that we are defining a function. But the fact that it is within a class is what turns it into a method. All right. So I'm going to do funcs within class are known as methods. All right. And the purpose of this method is, again, to build an instance of the dog. Well, how would we do that? Well, let's take a look at our roadmap here. We're going to back out a little bit. This is the init method. It is the constructor. What the init method does is it takes in properties or values that we're going to be passing into this function. And what it's going to do is it's going to provide us an instance of the dog Shadow. Well, this machine knows I have to take in materials and I have to output materials, but it doesn't know what materials it needs or what materials to output. And that's where our blueprint comes in. So let's start implementing this blueprint. We know we're going to need a name for this dog, which for now I'll leave as a string. We know that this dog is also going to need a height. It's going to need a weight. What else do we have in this handy dandy thing? We have a lifespan. Just adding some default values there. We have color. Let's see. Breed, color, weight, height, lifespan. Great. And let's just do temperament as the last one. All right, now all of these are now values that we are expecting for this class. But as of now, these aren't tied to anything. If we're talking about scope, all of these variables only exist within the function of init. And we need to find a way to tie it back to the class. That's where the self keyword comes in. Now, any method or every single function, every single method within a class, the very first argument it will receive will be self. Now, self is in reference to the class itself. That could be a little confusing. Well, what do I mean by that? That means that self.name now gives the class of dog an attribute of name. So later on, I can say dog.name. And you can see that that is recognized as a string. I can turn this into self.height. And now there should be an attribute named height. Right? It's not able to recognize it now because I haven't finished the constructor, so it's kind of having some trouble reading my information. But that's essentially what's happening. By adding the self keyword, I'm saying these aren't just variables that are only supposed to be existing within this init method. These are variables that have to exist within the class. So I'm going to say self.weight, self.lifespan, and self.color. Finally, self.temperament. All right. Now I've covered quite a bit of information up to this point. We went ahead and implemented the init method, and we just covered over the concept of self. At this point, does anyone have any questions over how this init method is working and how we're turning that blueprint that we're seeing in a visual aid on TLDraw into an actual Pythonic program? Okay, fantastic. Doesn't seem like we have any questions up to this point. So let's keep moving forward now. Well, here in this visual example, when I'm looking at my init method is expecting to take in properties and then give me an instance of these properties. But if I go back, currently my init method isn't taking in anything, right? Again, this keyword of self is just referencing to the dog itself. But other than that, there's no other attributes that are coming in. Well, we got to fix that. We know that we're going to need a name. We know that we're going to need a height, a weight. We need a lifespan. We need a color. And we need temperament. Now, all of these attributes are going to be coming in from outside. Right? When I go to actually build an instance of this class, I'm going to be passing in each key or each attribute to the init method. We'll go into that here shortly. This might make it confusing, so let me go ahead and do this number. Let's do my dog, which again is going to be the dog class. And what I want to call is going to be the init method. Now, this init method is going to initialize where name is equal to shadow, where height is, I don't know, let's go with 30 inches. Why not? Where weight is, let's go with 90 pounds. Lifespan, that would be a little bit harder to pass in. I'm just going to put 9. Color, let's do brown. And then temperament, well-mannered, good dog. We can see how name matches here, the height, the weight, lifespan, color, and then our temperament. Each one of the attributes are being passed in. We're not passing in self because, again, self is a keyword that references to the class itself. So by calling the dog class, we're already passing in self. It's being passed in automatically for us. Now let's see what happens when I execute the script. Okay, I'm getting an error here. This game, we're missing one positional argument. 1, 2, 3, 4, 5, 6. Okay, let me go ahead and take this init off because I think calling it manually is actually causing some errors here. Okay, there you go. So now when I call it, this is all working well. And if I go to print my dog dot name, what I'm going to see is going to be an empty string. Nothing is being passed in, but the instance of dog is being constructed. And all of these attributes are being passed in. Now, let's say I wanted to pass these in a separate order, right? Because that does sometimes become a factor. Sometimes I need to pass things in a separate order. I don't want to have to deal with manipulating things to pass them in correctly, et cetera, et cetera. Well, what if I wanted to do something like, hey, I want to pass in the name? Well, you'll see the rest of them got highlighted in red. Let's try to execute the script and see what kind of error we run into. Well, here we're seeing positional arguments follow a keyword argument. Interesting. Well, these are the positional arguments, meaning that it's assuming that I'm handing them in order. And this here is a keyword argument. Well, if I do it this way, now there's no error. And if I try to execute it, well, manner, dog, name, got multiple values for argument name. It kind of starts running into some issues here because what it's doing is it's trying to place 30 as the name and so on. So it becomes a little bit tricky. In order to effectively do this, I would have to say, hey, the height is equal to this. The weight is now equal to that. Lifespan. Color. And then finally, temperament. And now if I execute it, I don't get an error and it's able to execute correctly. So I could either pass in order everything that needs to fall into this init method, or I can say specifically what each attribute is supposed to hold. All right, does anyone have any questions over how we pass in information into the init method? Perfect. So there's no questions up to this point. But I have a question for all of you. Currently, when I print my dog.name, why is it that I'm not seeing shadow? What's happening here? Let's hear it, Tom.
You're not returning a value. You need a getter.
Okay, that's good. That's a good start right there.
Well, because of encapsulation.
Nice. All right, Rick.
Yeah, I was gonna say all of that. Yeah, you're not returning any kind of value. And I didn't think about the encapsulation, but yeah, encapsulation, like you said, you'll have to get a getter and pass that to the result or whatever you're passing out of the function or the object.
All right, awesome. Those are definitely good starting points. All right, go ahead, Chris.
Yeah, I was just gonna say I think self dot name should be because you got an empty string there. It's already being defined by an empty string.
All right, that would be it. All right, everyone. Good points to point out. We still haven't worked with getters or setters yet, so that's the reason why we're not seeing their implementation as of now. And this function is definitely not returning anything, but it is setting attributes, right? Or excuse me, this method is not returning anything, but it is setting attributes. Currently, my attribute's not being set to the name that's being passed into the method. It's just being set to an empty string. So in order to fix this, I actually have to connect the dots. All right, I am passing in the name into the dog class. That then feeds it into my init method. We can see that name is expected here. But finally, I need to pass in that value into self.name. Right, so now let's go ahead and pass this in. We're going to fix this by saying self.name is equal to name. Self.height is equal to the height. We got weight, lifespan, color, and temperament. So now each one of them are being attached. Not only is it being passed in as an argument to the init method, it is also being set as an attribute for the class. Now, if I go to execute my script, let me go ahead and clear it so that we don't have too much white noise. You can see that the appropriate name that I get is Shadow. All right, so just a quick review over what we've done up to this point. We made a declaration of the class dog. My Python script now knows there is a class named dog, but I wanted an effective way for me to be able to manage all of the dogs in my pound. So now if I were to receive a CSV file with all of these heights and weights and all of these information for all the dogs inside of the pound, I could quickly write a Python program that iterates through each row of that CSV file and create a dog for each one of them. And if I wanted to view all of their names, I could just print their names as I move forward. All right, the way the init method works, again, self is in reference to the class itself. All of these are arguments that it expects to be passed in. We can see that we're passing in values to those arguments down below in line 19. And the constructor, or excuse me, the init method will actually set those arguments as class level attributes. So self.name now holds the value of the argument that was passed in for name. At this point, does anyone have any questions over everything we've done? Go ahead, Alex.
When you're passing in your arguments into that my dog variable, now that we've given the self.name equals name, will you still need to do name equals shadow when you're passing in that argument? Or will just shadow in the correct order work?
Yeah, it's a great question. If I pass it in the correct order, so let's say I do shadow, and then I cut it off, that would work. All right, because it's assuming that the very first argument that gets passed in is the name. All right, any other questions? Let's hear it, Tom.
I think I see where I went wrong with the last question. Is it's returning a value because we haven't privatized those variables, right?
That's right. They have
Okay,
not been
okay.
privatized. Awesome. Rick?
Yeah, I might already know the answer, but it'll probably throw an error. But what if you decide to give it a pass it something that it's not asking for? So you do shadow, height 30, weight 90, lifespan 9, color brown, temperament well-mannered, good dog, and then you pass in something like disability 3-legged or something like that. It would probably just throw an error because disability is not part of the class.
It would, yes. So once I pass that in, it's going to throw an error. It's going to say it got an unexpected keyword argument named disability. And if I don't pass in a keyword argument, let's say I just pass in, hey, there's this 3 legs argument at the very end of it, and I try to execute it, it's going to tell me that I got too many positional arguments. Oh, this one is. Let me go ahead and change it this way. Oh, I think I would have to reset the class to be able to demonstrate it, but it needs the same number of arguments that it's expecting is how many should be passed in.
Okay, and, oh, sorry, go ahead.
No, go ahead.
I had a second question. Kind of goes along with one of my questions on the second day. So is there a way to pass an argument from another class?
There will be, yes. And we'll be
Okay,
talking
so
about
that's
that.
later on. All
Yeah,
right.
that will be later on.
Okay, all right, that's good.
Awesome.
I'm-
Arnold? I think you had your hand up, right, Arnold? Or are you good to go?
Oh yeah, so can I just do my dog dot disability and then it's equal to 3-legged? Can you do that?
You can, yeah. So if you want to add an additional argument, you could do something like my dog dot disability, and then make that equal to 3 legs. And then that would work. All right. And if we wanted to see it later on, we can print my dog dot disability. But you'll see if I do it this way, it's not going to recognize that you have that argument. It is going to retain the information. This isn't common practice, and I don't recommend doing it this way. One, it's a lot of repetitive code if you have multiples that you have to manage this way. If you do have to account for disability, I would probably make that a separate class and then utilize composition, but we'll talk about that later on. Does that answer your question, Arlen? All right, fantastic. And then I saw another hand go up.
It was mine. You already answered.
Perfect. All right. So now we've talked about all the attributes. We understand how to make a class, but there's something else that I want to talk to you guys about. What happens if I just print the class itself? Well, if I just print the class itself, it gives me this weird information. What does this actually mean? And this is important for us to understand so that if you ever see this in your terminal, you can recognize what's actually coming in. What this is telling you is that in the script named main, because that's what my script is named, main.py, there's an attribute, or excuse me, there's a class named dog. So here's the class of dog. Now, when I make an instance of this class, that's what turns it into an object, or what we know as an object. All right, so an instance of this class is an object. So it's telling me in the main script, there's a class named dog. We are saving an instance of this class at, and what this is actually providing me is a memory location. It's saying in the following location, memory location in your machine is where you're going to find the instance of dog. Now that probably raises a couple questions. Well, what happens when my Python script's over? Am I just constantly occupying memory space? No, Python has its own garbage collection and its own way to work in the background. So at the end of your script, anything that Python utilized as far as memory locations or memory overall, it goes through your machine and pretty much dismounts itself once it's completed running your script. All right. Well, that isn't very useful, being able to see this print my dog. So maybe I want something a little bit more, with some more umph, right? I want something more descriptive. Well, that's where we can create another built-in method called the string method. Now you'll notice these 2 underscores in front of them. These 2 underscores is what makes these methods known as dunder methods. So I'll go ahead and add that here into our notes. Double underscore marks a dunder method. Meaning that these are default methods that are already pre-programmed for us. Whoever came up with OP inside of Python said, this is a common thing that we're going to need. It's going to be a common tool. So we're just going to create all of these methods already. Now, how do they do that? Well, there's a class somewhere that describes how to write a class. And that's where they created this method for a string. All right. So again, what's the very first argument that a method should take in inside of a class?
Self.
Right, so we're going to take in self as our very first argument. And this method is actually going to return something. It is going to return a string. And what the string is going to be is a representation of the class. So I would like this to say, hey, I want self.name is a dog that weighs, and let's go with self.weight with temperament, and then write out temperament. I knew I was going to mess up eventually. Oh, there you go. Self.temperament. I thought it was a misspelling. So now, instead of seeing a memory location for line 24, when we execute this code, we're going to get the return of this string. We get Shadow is a dog that weighs 90 pounds with temperament of well-mannered good dog. Again, we take off the string method. I execute my script. I get a memory location. Not useful, really doesn't help me. It's great that I know there's a class object, but which class object is it that I'm interacting with? Well, let's fix that. I want to actually see some information of the class object I'm interacting with. I run the dunder method. And I get Shadow is a dog that weighs 90 pounds. A little bit more descriptive. Does anyone have any questions over the dunder string method? Perfect. Now let's start actually diving into some behavioral methods. Oh, excuse me. Go ahead, Rick.
I think I already figured out the answer too. Sorry. So you can pass a string. I'm sure you can pass other things like lists and different things like that as well, or turn it into a list or anything that we've already gone over in the last week.
Not in the string method. The string method specifically requires you to return a string.
Yeah, but I'm sure there are other methods like a def list or something like that where it'll return a list or anything else.
There are going to be other methods that we'll dive into to handle for that in case you want multiple instances to be represented in a different way. That's going to be the representation method, and we'll talk about that later on.
Okay.
All right, awesome. So now we have our initialization, we have our string method, and we have a working class for this dog named Shadow. All right, if we take a look at our roadmap here or this little image, we made our class declaration with our init method. Our machine now knows how to work. We hand in all of the proper data, whether it's integers or strings to be represented. And then what we got was my dog or Shadow being a class instance. So we have our class instance here in line 23. We have our blueprint right up above in line 8 all the way down to line 16, or excuse me, all the way down to line 20. But our dog has no behaviors. So if we wanted to add some behaviors, this is where things are going to get a little bit, they're pretty straightforward, right? We want to add some behaviors here. Let's say I want to say that I want my dog to speak. Well, now my dog can simply just return bark. And I can change this to say, print my dog speak. Now, because this is a method, it is a function, so we have to actually call it. All right, so that's why we see those opening and closing parentheses. And now we can see that it barks. Let's say I want to build a method. And let's say I build a new here. I'm going to build a new attribute called aggravated. And I'm going to turn this into a default of false. Right. Okay, I'm not sure how to spell that, but we know that aggravated is in there. Well, let's say we have a change mood method that takes in self. I'm actually going to grab this good temperament thing. Well-mannered dog, good dog, perfect. And I'm going to say, hey, self.aggravated is equal to not self.aggravated. And then I'm going to say if self.aggravated, so that means it's angry, I'm going to change temperament to bad dog. And then else self.temperament should be equal to good dog. Now, this method doesn't return anything. Instead, it changes values for temperament. Right? I can say I want to print my dog.temperament. I'm going to do my dog.change mood. And then finally, I'm going to print my dog.temperament so that we can see what's being represented there. Well, we can see the bark from that speak up above, a well-mannered dog, which is a good dog, and then we see bad dog. So there's another example of a method that can be placed within a class. Right, just to add a little bit of logic in there. Now, let's say that we want to fetch. Well, I want my dog to be able to fetch information. And I want this to actually take in an argument. In this case, the argument that I'm going to be taking in is an item. Well, now I can just return an F string. Well, I say self.name is fetching item. Now, these methods are just string manipulation or just return string. But we'll see how these methods can grow and change in behavior as we continue on with the program. So here I'm just going to go ahead and fetch. And what I wanted to fetch is going to be a ball. Now, when I run it, we see bark from the speak method, and then is fetching a ball from my fetch method. All right. Any questions over methods for classes? Well, what happens if I'm holding into two dogs, right? So far, we've only seen Shadow. Let's see what happens if we have Leslie here. We're going to do dog. The name that we're expecting is Leslie. The height that we're expecting is going to be, let's do 35 inches. The weight is going to be 100. Lifespan, let's go with 10. Color. You can also see that my editor is kind of telling me where I'm at when I'm going to create. Let's do gold. And then temperament. Let's finally do that dog. Well, currently, this whole time, I've been interacting with Shadow. If I run this, we can see that everything comes back for Shadow. But these methods, because they're part of the blueprint, I don't have to recreate them. I could just simply change what dog it is that I'm working with. If I change it to Leslie and then run it, we can see that Leslie is also able to bark, and Leslie is also able to fetch a ball. Leslie also holds all of the same attributes the shadow did. And that's kind of one of the biggest benefits of object-oriented programming. Right? When Leslie came in, I didn't have to recreate all of this. I didn't have to add any more methods or rewrite the function or some of the logic that interacted with said function. All of it is made once and then reusable for all of the instances of that dog, which again follows the dry principle of don't repeat yourself. All right. At this point, does anyone have any questions over everything that we've covered in part 1? Okay, let's do a quick recap of the lesson here. We went over how to declare a class. We then talked about the init method. The init method and any method that falls within the class, the very first argument that it receives itself, and that's in reference to the class itself. We then have arguments that are going to be set as class attributes. Here we can see self.name sets it to the name, self.height sends it to the height coming in. We see that all coming together whenever I pass in shadow into the constructor, or excuse me, the initializer down here. So at this point, I am initiating a class. In line 30, I initiate the class of dog. All of the arguments that are passed in are set as attributes for the class. We then cover what a dunder method is, which is marked by 2 underscores. We talked about the string method, and then we built our own methods, such as speak and fetch. All right. At this point, are there any questions over anything that we've covered for part? Let's hear it, Arnold.
What's the difference between the dunder str and the fetch? Because they're both just passing, returning
A string? Yeah, that's a good question. So the string method specifically is utilized to, let me write it in here, utilize to represent the class instead of memory location. While these other two, they're simply functions known as methods that just happen or that return string. Does that answer your question, Arnold? I see the thumbs up. Go ahead, Rick.
Yeah, that actually brings me to another question. So the speak function and the fetch function, you're passing self into. I guess you're not able to put multiple classes inside a single file. You would need to separate them into another file. Because if you have like another class, like say cat, and then you would have to give it something besides self. You'd have to give it like, self feline or whatever.
Yeah, it's a great question. And you could still have multiple classes in here and just change the name. You could pass in self because self is only in the scope of the class. Right. So because we have this indented portion down here, it knows that every time it's referencing to self.
I see.
Are referencing.
So, okay, so you can only access the class from inside the class. You can't access it from outside the class.
You can, but it's not common practice.
Okay, all right. So that's encapsulation. Yeah, because you can only access it from inside the class. All right, cool. I'm understanding.
Awesome. Go ahead, Arnold.
Just to clarify, so in str you can only pass the parameter self, and that's about it. That's the main difference between those str and the fetch. In the fetch, you can put in the self and something else.
That's right. So in speak and fetch, since these are just our functions or our methods that we're creating, we could pass in as many parameters as we want. This one is already pre-programmed for us. It has already been made with specific information, so it only takes in self and does not accept any other arguments.
Okay, thank you.
Of course. All right, fantastic. I'm not seeing any more questions, so this is going to conclude part 1 of our lecture, everybody. Going to go ahead and stop the recording here.